This is an introduction to hypothesis testing for proportions, which is the last type of hypothesis testing that we learn about in this course. And so we really have just one learning target, and that is we want to learn how to use a z-test to test a claim about a population proportion. In a z-test for a population proportion, we're basically trying to determine if we have evidence that is in favor of or opposing a claim that's made about a population proportion. Now, in order for a z-test for a population proportion to be a valid one, we need to be sure that n is large. And n is large when n times p is at least 5 and n times q is at least 5. And remember from our confidence intervals, q is just 1 minus p. So it's the complement of p. So we're going to be calculating a test statistic. We call it a standardized test statistic. And when dealing with proportions, we remember from our confidence intervals, we are in the normal distribution, in large part because proportions have a very limited number of possible values. Proportions have to be a number between 0 and 1. Well, that's not a very large interval, and therefore proportions snap into the normal curve much more easily than do means. Means can have just a whole bunch of different values, and so they have a much wider interval. So you'll notice that what we're going to do to calculate the standardized test statistic is we're going to need to take our sample proportion p hat, subtract the mean of p hat, which is going to be the claimed proportion p, and then divide by our standard error. This standard error formula should look familiar because we used it with our confidence intervals as well. It's the square root of pq over n. So our steps in a confidence interval for a proportion are first to verify that the sampling distribution of p hat can be approximated by the normal distribution. And that's where we check to be sure that n is large. Is n times p and n times q, are they both at least 5? Second, of course, is where we're going to state our null and alternative. Third, of course, is where we're going to need to identify the level of significance alpha that's given to us. Fourth, use our table, the infinity row, to determine our critical value and then our rejection region after. 6, calculate our standardized test statistic using that formula we just showed you. 7th, make a decision. Should we reject or not reject the null? And then 8th, identify what that means about the claim in the context of the problem. Let's try this. Let's say that a researcher claims that less than 50% of U.S. adults have accessed the internet over a wireless network with a laptop computer. So they're claiming that the percent or proportion is less than 50%, which would be 0.50. That is the claim. Notice that claim is not a statement of equality, so that belongs in the ha. The ho then would be the complement of that. Well, the complement of less than is greater than or equal to. Okay? In a random sample of 100 adults, so n is 100, 39%, well, that's our sample proportion, p hat, 0.39. Say they've accessed the internet over a wireless network with a laptop computer. At a level of significance equal to 0.01, is there evidence to support the researcher's claim? So we've identified our null and alternative hypotheses. Let's verify that the normal distribution is an appropriate tool. So is our NP and our NQ at least 5? So N is 100 If I multiply it by P, the 0.50 claimed, I get 50. That is at least 5. If P is 0.5, then Q is 1 minus 0.5, which would also be 0.5, and therefore NQ is also at least 5. So we verified that the normal distribution is an appropriate tool. Next, we want to find our critical value, okay? So our critical value, Z sub 0, MyLabs Plus uses, can be found using Table 5. We go all the way down to the infinity row now since we are in the normal distribution. And so we were given a level of significance of 0.01. So we find the column for one tail, 0.01, and then go all the way down to the infinity row, and we see that our critical value is 2.326. Because our alternative hypothesis said less than, we are doing a left-tailed test, and so that means our critical value needs to be negative. And so you see down here in my picture that I have identified a critical value at about negative 2.33. You can see that's between a z-score of negative 2 and a z-score of negative 3, but it's a little closer to negative 2. We want to find out now if our sample proportion gives us a test statistic that's in that region out beyond negative 2.33, which is our rejection region. So we're going to take our formula, find Z by taking our sample proportion minus the claimed proportion and divide by the standard error for the proportion. So our sample proportion was 0.39. In the null, we said that P is 0.50. Our standard error would be the square root of 0.50. It's square root of P, not P hat, Q. So Q is 0.50 as well, 1 minus 0.50, divided by the sample size, in this case 100. Now do this with me on your calculator. You should end up with a Z test statistic of negative 2.2. Well, notice down here in gold, negative 2.2 isn't quite far enough. It's close, but it's not far enough to be in that blue rejection region. So that means we fail to reject the null. That means there is not sufficient evidence to support the claim, to support the claim that less than 50% of U.S. adults have accessed the internet over a wireless network with a laptop computer. So that's an example of a hypothesis test for a proportion where our alternative resulted in a left-tailed test. So let's try one that's a little different. The research center claims that 25% of college graduates think a college degree is not worth the cost. So I can see it's about percentages, so it's P, and they're making the claim that that 25%. It didn't say less than, it didn't say greater than, just that 25%. So that means equal to 0.25. That is our claim, and we know that the statement of equality always belongs in the null hypothesis. So the complement of that would be in the alternative hypothesis, which would be not equal to 0.25. You decide to test this claim and ask a random sample of 200 college graduates, so N is 200, whether they think a college is not worth the cost. Of those surveyed, 21% said yes. There's our sample proportion P hat, 0.21. At the level of significance equal to 0.10, is there enough evidence to reject the claim? So first we've got a random sample, we want to see if the normal curve is an appropriate tool. So is N times P at least 5? Well, 200 times 0.25 is 50. That's at least 5. Is N times Q, which would be 1 minus 0.25, also at least 5? And clearly it is. That's 150, which is clearly more than 5. So the normal curve is an appropriate tool. Okay? So we're going to proceed and we're going to identify our critical value. Now notice this time we're doing a two-tailed test because of the direction of our alternative hypothesis. So we're going to need to go to 5, look up two-tail, find 0.10 in the two-tails alpha row, second column, go all the way down to the infinity row, and you see your critical value is 1.645. Now, because this is two-tailed, that means we've got a critical value at positive 1.645 and a critical value at negative 1.645. So here's the negative, here's the positive. Notice it's between 1 and 2 and between negative 1 and negative 2. The rejection regions then would be out beyond those two critical values. So they are the blue tails. If our sample proportion produces a test statistic that lies in either one of those tails, we're going to reject the null hypothesis. So let's calculate our Z test statistic. We take our sample proportion, 0.21, minus the population proportion in the null, 0.25, and divide by our standard error, the square root of PQ over N, which would be the square root of 0.25 times 1 minus 0.25 over the sample size. And when you compute that, do this with me to make sure you do in fact get the same value I do. You should get negative 1.31. Well, negative 1.31 you can see is marked down here in gold. It is not in the rejection region. It's close, but it's not there. It is in the non-rejection region. And therefore we do not reject the null. Okay? So we can say then that at the 10% level of significance, there is not enough evidence or not sufficient evidence to reject the claim that 25% of college graduates think a college degree is not worth the cost.